Yes, ma'am.
Okay. So what I was telling about the overview of a computer system. So in the overview of a computer system, what I discussed, I am comparing uh, your I'm comparing a human with a computer. What I'm trying to say is just analyze how we human work. We human work in a particular way. What is the way? The way is something like this, that we have a memory, and depending on what we have learned so far over the years, we remember that we once we get up in the morning, we will brush, we will take bath, we'll take breakfast, we'll go for work, we'll go for office or go for school, etc., etc., and do all household work. And this is how the whole system works. And every individual is equipped with certain uh, work. Like, I am a teacher, you are a student. There are some who are a worker who is working in the field. Some are farmers who are working in agricultural land, and so on and so forth. So every people have a designated work. But how am I able to teach you, how you are able to grasp this? So there is a memory component which is involved. Okay, so this is really an important concept, and all of you must understand this, that a computer system consists of a processor. I'll talk in details what a processor consists of, but memory is an integral part. Why? Because without a memory, nothing can be done. Memory is the place where the instructions and everything are stored. Same with our human memory. We know that how we have to do our household work or day to day life work, because everything is stored in our mind. Now, at this point of the time, I'll not confuse you, but when you go further in your courses, and you will see that what is machine learning and all, you will see that that is also so much related to our human thing, because human have learned over the years, and how our human mind is learning in the same way, we are equipping the computer system to learn certain things. Okay, fine. Let us come to the overview of a computer. Someone is still coming or what? Just a second. So, uh, so this is a basic architecture or basic broad overview of a computer system, where we have memory, and I have discussed memory is an integral part, and we'll see further that how memory is so very important. We have processor. Processor consists of two important components. What are the two important components? One is control unit, and another is arithmetic and logic unit. You already have learned many things which are there in arithmetic and logic unit, like adders, like multipliers, multiplexers, registers, everything. You already have learned so far. Now, what will be your job? How we will be able to realize an arithmetic and logic unit using these components which are already in place. And we have input devices and output devices. So think of a computer system. A computer accepts input, processes that input based on the instruction provided in the memory. From the instructions which are provided in just a second. So, yeah. So the instruction or the input that is provided, which is stored in memory,
हेलो কি হলো?
ম্যামের নেটওয়ার্ক কানেকশন হয়ে গেছে আই গেস, লেফট হয়ে গেছে ম্যাম।
ও আচ্ছা
একটু
আচ্ছা।
ওয়েট কর, এসে যাবে।
hello everyone. At what point of time I got disconnected?
Ma'am, the input device and memory part.
Okay, okay. Just a second. Are you able to see this slide?
Yes, ma'am.
Okay. Okay. So now you see what I'm trying to say is that if you consider this whole system, whole computing system, uh, you have your input device which will provide the input to the entire system. The processor takes the input, basically stores, or the memory wherever it is stored. Memory consists of instructions. So everything which the processor executes must be stored in memory. And from the memory, each of these instructions are passed to the processor. The processing takes place in this processor where the control unit generates the control signals and necessary actions takes place. And finally, it is provided to the output section, which is the output device, where we see in the screen or we output it or provide it to some other input to other device, etc., etc. Now, this concept of storing the programs or the data in the memory, okay, in the memory, what we are storing? Programs and data as well. Both are stored here. And as and when it is required, we bring the data and programs to the processor. It gets executed here, and again, it goes to either memory or to the output device. The concept of storing the program and data into the memory and bringing it to the processor is known as von Neumann architecture. Okay, way back in 40s, von Neumann suggested this architecture. And why and how he architected this, why he suggested this, you just think of your human mind here. Because we couldn't have done anything if we do not have a memory. Otherwise, we do not remember what to do. So our brain, where all the instructions are stored, are fed to a system, to various other parts of our body, and then we do those work. Although we have learned it over the years, but We are doing it just because everything is stored in our memory. That is nothing but our programs and data. And processing takes place with, somebody says, okay, oh, I'm smelling something. Okay, so let's do this. Let's go out of the room. Why the smell is coming, or something like that. So this is referred to as von Neumann architecture. Can I move on?
Yes, ma'am.
Okay. Now just
Yes, ma'am.
understand what is there
Yes,
inside
ma'am.
the processor. Inside the processor, which is called the central processing unit, it consists of two parts. One is control unit and another is arithmetic logic. You think of one thing, you already know many of the electronics component like the adder, encoder, multiplexer, registers. What are registers? Those flip-flops. Combining these flip-flops, we will see registers, shift register or any kind of register in tomorrow's practical class. But we already have designed individual components. Okay. Now what we will do for building the processor, we will require those components. We will combine it in such a fashion such that it realizes my arithmetic and logical operation. Okay. So CPU consists of two things. One is control unit, another is arithmetic logic unit. All the calculation happens inside this arithmetic and logic unit. But what control unit does, it basically generates the sequence of control signals to carry out the operation. Now think of a situation. You need to add two numbers. If you need to add two numbers, there could be many possibilities. We will see further that it could be only certain operations that are performed on registers, or it could be certain operations where the data is stored in memory and we need to bring the data from the memory to perform the operation. Okay. So in such cases, who will tell the computer? Computer is a layman. Understand this. It is we human who has built this computer and who instruct the computer to work in that fashion such that it work in that way. And who does it? This control unit. If we have to perform, let's say, add R1, R2. What is R1 and what is R2? These two are nothing but, let's say, processor register. Processor registers. We will see what is a processor register, but for the time being, you understand that inside the processor, there are registers. What is a register? A register is just nothing but a combination of flip-flop, where certain bits of data are stored and certain bits of data are also read and written. Okay, we read from that register or we write something into the register. Fine. So to perform this operation add R1, R2, the control signal will generate the required various control signals to carry out the operation. We'll see what are those instructions in course of time. So the processor fetches an instruction from memory. Okay. Processor fetches an instruction from memory for execution. But what is an instruction? An instruction specifies the exact operations to be carried out. It also specifies the data that is to be operated on. A program refers to the set of instructions that are required to carry out some specific task. So let us see what is a job. I'll explain this in a separate page. Let's go here and let me explain. So what did I say? There are few things that are there. First is, this is your processor, let's say. This is your processor. Processor consists of many registers. Let's say R1, R2, etc. Many more. What did I said? Memory consists of instructions and data. Okay. So what kind of instructions? Let's say my instruction could be adding 10 numbers or adding 2 numbers. So for simplicity, let's say my instruction is adding 2 numbers, which I'm writing it in this way. Add R1, R2. Fine. Now, this add R1, R2 is called an instruction. And where it is stored? It is stored in memory. How will I execute it? First of all, I need to bring this entire instruction from memory to processor. Once I brought the data from memory to processor, now it's the job of the control unit to generate required control signals. Now you tell me, what kind of control signals might be required for executing this instruction, executing this single instruction? Can anybody tell me? Yes?
Hello, ma'am.
Yes?
Ma'am, can you please describe the picture because my network is little poor, so I can't listen anything, please, ma'am.
Okay, sure. What I'm trying to say here is that this is the processor, okay? Processor has got certain registers which are local to this processor, okay? It has got many other registers, we'll see that. But now for simplicity understand, let's say it has got 2 registers. The name of the 2 registers is R1 and R2. Memory consists of data and instructions. This add R1, R2 is an instruction. So what is an instruction? An instruction is nothing but an information that is stored in memory and that will be sent to processor for execution. Add R1, R2 is an instruction. If you see add R1, R2, this total instruction consists of 2 parts. One is basically called opcode, and the next part, this whole part is called operand. Is it clear? An instruction consists of an opcode. What is that? An operation that is to be performed. It could be any operation. And along with opcode, it has got an operand. What operation it will perform? On which value it will operate? It will operate on R1 and R2. So an instruction consists of 2 parts, opcode and operand. In this instruction, this is an opcode which is add, which is nothing but adding the content of R1. R1 is a processor register, and R2. R2 is also a processor register. And then what it will do? Then what will it will do? It will add and then it will store the value. So add R1, R2 will do what? It will add the content of R1 plus the content of R2 and store back in R1. So you might ask me, why not, ma'am, in R2? So the convention that is followed, and I will follow throughout my lecture, is that the first operand will also be the destination operand. Okay?
Ma'am, can you please repeat this part? I was disconnected.
Okay, sure. So the instruction add R1 comma R2 is nothing but R1 equals to R1 plus R2. Meaning what? The content of R1 will be added to content of R2 and then will be stored in the first register. So this is my destination register. Is till this point, is it clear to you? We have an instruction, a single instruction here which is stored in memory. What is an instruction? An instruction consists of two parts, operand, opcode and operand. Opcode is what operation needs to be performed and operand is on what that operation will be performed, which is nothing but this R1 and R2.
Ma'am, please say
Fine.
again opcode and operand.
Okay. Opcode is basically this one. Opcode is this one. Add R1 comma R2. Let's say it could be also move R1 comma R2. It could be mul R1 comma R2. Okay. So in all the cases, this add, this move, this mul is nothing but an opcode. Okay. Opcode, meaning the operation to be performed. And this are nothing but, it is operands on which this operation is performed. Fine. So an instruction consists of two parts, opcode, operand, and operand is nothing but yes? Yes?
Ma'am, what is
I could not hear you guys.
Here add means addition, mul means
Add means the opcode, operation to be performed. Okay. No, add means, yes, of course, add means addition, mul means multiplication. But how will the computer know that?
Ma'am, she was asking like add means addition and mul means multiplication. Then what is move?
What is move? Move means moving.
Ma'am, it is just a action which we command the computer. So
okay, yes, absolutely.
According to this command,
I know, but
will
what
perform
is
certain tasks.
Yes, ma'am.
Move means we move the content of R1 to R1. Let's say R2 contain value 10. This 10 will be transferred to R1 after executing this instruction move. Is it clear?
Yes, ma'am.
Yes, ma'am.
Who was asking?
Yes, ma'am.
Shiny or who? Shiny. Okay.
Ma'am, Shiny was asking.
So move means just
yes.
moving from one register to another. Okay, I'll talk about all these things in course of time. But for you to understand, just understand what is an instruction. An instruction means some operation. It could be any operation. It could be XOR operation. It could be AND operation. It could be any other operation. And on what it will operate, on what it will perform the operation, on certain operands. Here, another important thing you have to remember, these R1 and R2 are all processor registers. This R1 and R2, I told it is processor register. What is a processor register? Processor registers are certain registers that are local to processor. Inside the processor, you have those registers, and register stores certain value. But memory is a separate part. You connect processor to memory. If this is processor and this is memory, you connect these two using certain wires, certain lines of wires. We call it bus. Okay. So remember this. if an instruction consists of processor register, that means it is local to processor. So for add R1, R2, the R1 and R2 are both processor register. But let us take another example, which is add R5, LOCA. What is LOCA? Now what I told you, memory will consist of data and instruction. I told you in the very beginning, you think of your mind. Your mind consists of many instructions. You know you have to brush, but you also have the data that where is my brush? You also have the data where is my paste, so that you will be able to perform that task. In the same way, the instruction add R5, LOCA is nothing but an instruction where one operand is processor register and another operand is memory location. That means when I say this is a memory, okay, when I say this is a memory, so all these will have certain address. A memory has certain address. I'll talk about this in the next lecture very detailed, but for now you understand that a memory will have certain address and these are the data which it will have. Because then how will I know that I have to go here and take this data, take this instruction and bring it to the processor? I need to know this memory address, definitely. Then only I'll say that from this memory address, read the data and bring it to the processor. Clear? Now, this instruction is nothing but an instruction where LOCA is nothing but another location. LOCA is another memory location. So now, unlike the previous instruction which was add R1, R2, this instruction has got an memory location from where I need to get the data. It is not like that the data is present inside my processor. The data is present in another memory location, which I have to get. Let's say this is 50, which I need to get from here, bring it to processor, and then this operation will be performed in arithmetic and logic. Till this point, is it clear? If you have any doubt, please go ahead and ask me, because this is the point. If you don't understand this, you will not be able to perform anything further. So please ask me.
Ma'am, please repeat this part once again from first.
Which part? Storing add R5, LOCA.
Yeah, yes.
Okay.
Yes, ma'am.
So my instruction is add R5, LOCA. And the idea is the operand could be processor register, or it could be a memory operand. Clear? So in this case, add R5, LOCA, one of the operand is a processor register and another operand is a memory operand. what it will do? It will add the content of R5 with the content of LOCA, because LOCA is a memory operand. This is our memory. This is our memory. Okay. Each memory has got an address. So when you buy a memory, you say, na, 4 GB memory, you have 8 GB memory, you have 10 GB or let's say 24 GB memory, 16 GB memory. So when you say that, that means that is the total memory you have got. Depending on total memory, and the number word size. What is the word size? These locations is defined. So these are nothing but memory location. Memory location. This has got certain address. Let's say I start with 2000. And generally these are written in hexadecimal. You already know hexadecimal, right? Hexadecimal number system, you guys know already, right? Yeah.
Yes, ma'am.
Okay. So if this is
Yes,
2000,
ma'am.
and if it is a 32-bit machine, I'll tell what is a 32-bit machine, what is a 64-bit machine, and so on. For now, you understand the first location will be, let's say my first location will be, let's say 2000. Next location will be 2004. If it is a 32-bit machine, why I'll tell you. Then it is 2008. What will be the next location?
2012,
Hexadecimal.
ma'am.
2012.
2012, right?
Yes,
But that
ma'am.
12 is, we call it 2000C. 200C.
Yes, ma'am.
Agreed?
Yes, ma'am.
Next will be C.
Yeah, yes, ma'am.
It will be
F.
200F, and so on and so forth. Right?
Yes,
Yes,
ma'am.
ma'am.
Sorry, this will not be C. This will be 10. This will be 10. This will be 10. Agreed? 2010. Agreed? The next location? 4 I am incrementing. Right? First is 0, then 4, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What is 16 is 10?
Yes, ma'am.
Okay. Now, why I'm incrementing it with 4? Why not 8? Generally, our computer in earlier days were 32-bit. You all know that? The word length is 32-bit. So this is 32-bit word. So this is a memory location. In this memory location, it consists of one word, which is 32-bit. The next memory location is 2004. It also consists of a 32-bit word. Okay? And in this 32-bit word, we can also store my instruction, which is add R1, R2, which is add R5, LOCA. And what is LOCA? LOCA is nothing but another location. Let's say 2100. And in 2100, we can have something called, let's say, value 50. So it becomes so clumsy. Let me draw it once more. Yeah. So this is my memory. So I told you there are memory locations. Let's say starting from 2000. This is 2004. I'm not saying why, but let's say we are incrementing it in this way such that it is incremented by 4. I'll explain everything in course of time. This is 10. Let's say my instruction is add, which is stored in 2004, add R5, LOCA. LOCA is nothing but some memory location. So ultimately, this instruction is add R5, comma, let's say 2010. And 2010 contain the value 50. And let's say R5 is a processor register which contains the value 20. Let's say, suppose. So if you want to execute this instruction add R5, comma, LOCA, what needs to be done is basically you need to get this R5 value which is directly in the processor. So remember one thing, memory is just for storing the data and instruction. No processing happens in memory. All the processing happens in your processor. Clear? So you need to bring the instruction, data, everything to processor and execute it, and either you can store the result back in memory or the result can be stored in a processor register. Is this concept clear, guys?
Ma'am, could you please tell the last one?
Okay.
The last one, please.
Okay. So the point here is, this is my instruction. My instruction, see my instruction, there could be many instruction, move, R2, R3, and many other instructions are there. Mul, R1, R2, and now there could be even more. These are the data. 2014, which contains 20, 2018, which contains tens, and all those things. What I said in the very beginning, memory consists of instructions and data. And this is how the instructions and data are stored in memory. These are the instructions and these are certain data. For processing, we need to bring the data from memory to processor. Remember this. For any processing, we need to bring the data from memory to processor. Everything is processed in memory and then it is stored back in your processor register, or it could be stored in your memory location depending on the instruction. Now see this instruction add R5, LOCA. R5 is a processor register. The content of R5 is added with the content of LOCA. What is the content of LOCA? What is LOCA? You tell me first.
Ma'am, memory location.
Memory location. What I said, LOCA is 2010 is LOCA. Okay. What is R5? R5 is 20. So R5 is 20 plus content of 2010. Content of 2010. All of you agreed or not till this point?
Yes, ma'am.
LOCA is 2010. So what will be there? What is there in 2010? You go to this memory location, 2010 contain the value?
50.
So it will be 20 plus 50 and finally it will be 70. Now I'm just adding it and showing it up. You know that in computer, you do 2's complement addition or 2's complement. Everything is represented in 2's complement and it is performed. The operation is performed. So you have to also perform it in that way. Clear?
Yes, ma'am.
Okay.
Yes, ma'am.
Is this clear? Can I move on?
Yes, ma'am, please.
Yes, ma'am.
Yeah.
Yes.
So now these points are clear, right? Instruction specifies the exact operation to be performed. It also specifies the data that are to be operated on, the operands. And a program refers to a set of instructions that is required to carry out a specific task. So all these points are done. What is the role of ALU? Arithmetic and Logic Unit. It contains several registers. Some registers are general purpose and some are special purpose for temporary storage of data. What does it mean? You have an instruction add R1, R2. Now see, you are adding the content of R1 plus content of R2 and storing back in R1 again. Okay. So for doing this operation, you need the value of both of these. But if you copy the value in R1, the previous R1 value might get spoiled. So the architecture demands that we have certain architecture such that some temporary storages are required. We will see in course of time that in architecture, when the entire thing is placed, that the data from R1 will come, data from R2 will come, and addition will be performed here, and the result will be the output. We connect many things. So we need some temporary storage. Is this clear? Yes?
Yes, ma'am.
Yes.
Okay. It contains circuitry to carry out logic operation, which is pretty obvious. You already know that there are many circuitry which are required, which is there in your ALU. So it needs. Yes? Anybody said anything? Okay. It contains circuitry to carry out arithmetic operation like addition, subtraction, multiplication, division, and many others. And during instruction execution, this is very important, guys. During instruction execution, the data operands are brought in and stored in some registers. So when we are performing certain operation, that is, again, if you call it add R1, R2, these register values must be brought in and stored in some temporary registers. Then we perform the desired operation and the result is stored back either in some register or memory. Is this clear to all of you? Okay.
Yes.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. What is the role of control unit? Now, I told you the nerve. What does our nerve does? If you have issue in your nerve, then probably you will not be able to perform many tasks. The nervous system is the most critical system, and so as in a computer system, because computer system is nothing but what we human can do. We are performing that using the resources that are available in this earth, right? The metals through which we can build digital components, the semiconductor metals through which we build digital components, and then anything which is there within this human imagination, we are performing everything out of that. So the control unit acts as a nerve center that senses the state of various functional units and sends control signal to control their states. So now you think of, for performing an operation which is nothing but, let's say it is like this: add R1, R2, R3. We will see what are these. These are 3 operand instructions. And the instruction goes like this: R1 equals to R2 plus R3. So for doing this, you tell me what is required. One by one. Tell me, guys.
Ma'am, processor registers.
Processor?
Processor registers, the R1, R2, R3, the registers.
Yeah. Yes, they are processor registers. All are processor registers. Okay. And when I specify memory location, I'll say LOCA or
Yes, ma'am.
mem1, mem2, like that. So
Yes,
if it is
ma'am.
R1, R2, it's so what needs to be done for this? What are registers? Nothing but collection of flip-flops.
Yes, ma'am.
Okay. So you must enable the output of the register such that content of R2 and content of R3 are available where that arithmetic and logic operation will be performed. So basically, you know what is an adder. You know what is an adder. So for the adder, you have to have two inputs, A and B. So
Yes, ma'am.
in the A, this R2 must come. In B, R3 must come.
Yes,
Then
ma'am.
you perform addition and store back the result in another register, which is R1.
R1.
Exactly. So these are the important thing that is to be done. One is enable the outputs of register R2 and R3, select the addition operation, store the output of adder circuit in R1. Okay. And when an instruction is fetched from memory, the operation called opcode is decoded by the control unit and control signal is issued. Can you tell me what is this? See, I very easily told you that, okay, I'll say add R1, R2, the computer will perform add operation. Then I'll say mul R5, R6, the computer will perform mul operation, and so on and so forth. Okay, but how it performs this operation? This is only because the control unit performs that. When it is add, perform this. When it is mul, perform this, and so on and so forth. Fine. Is this
Yes,
clear,
ma'am.
guys?
Yes, ma'am. It understand our instruction according what we are telling them, what we are
Yes.
instructing them.
Yes. And further, we will understand that computer can understand only 0 and 1.
Yes,
So
ma'am.
how we will interpret everything in terms of 0 and 1? Fine.
The binary bits.
Yes. Everything what you are seeing here must be converted into binary. Later we'll see everything. Step by step. Let's go step by step. So what is there inside the memory? Inside the memory, there are basic important things. Primary memory, or we call it main memory, which stores this active instruction. Whatever I was showing you, this add R1, R2 or anything. All these instructions are stored in primary memory. And secondary memory is nothing but the backup, where all your files and everything is stored. Okay, your disk basically, where your huge amount of data is stored. Processor, it works like a hierarchy. Okay, it doesn't accesses all the memories directly. So it accesses the primary memory directly. Rather, in reality, it doesn't access the main memory. It accesses the cache memory first. We'll read in details about cache memory in your computer architecture course next semester. But for now, you understand that the processor only have the direct access to primary memory or the cache memory. Okay.
Ma'am, there was primary memory means the RAM.
Yes, absolutely, the RAM. And the secondary memory is
The hard disk or SSD.
Disk, SSD, everything is your secondary memory. Okay.
Yes, ma'am.
And in reality, the memory system is implemented as a hierarchy of several levels. It is not that you have 4 GB together, that everything is only one memory. It is a hierarchy. And we'll see what is that hierarchy. And in that hierarchy, you have caches, primary memory, secondary memory. We'll see all these things in details in memory, but for now, you understand the broadly main memory and secondary memory. But what is the objective? The objective every time is faster memory. You go to a computer shop and you want a computer. You always say, I want a fast memory. You give me some configuration where you have enough memory such that it is faster. We'll look into all these things in details. What is input unit? Input unit is nothing but it is used to feed data to the computer system from the external environment. Okay. Data are transferred to the processor memory after appropriate encoding. Commonly, devices are keyboard, mouse, joystick. I mean, these you already know, right? Input devices through which we provide the input. And basic computer operation we have seen today, isn't it? And a computer performs, executes certain instructions. But we have not spoken one thing, what is a program? I just told you about a single instruction, isn't it? But what if you have to add 10 numbers? Or you have to multiply 4 numbers. How will you do it? So for that, only one instruction. So it is not that single instruction, but you need to know how to write this with number of instructions. So when we have number of instructions together, we call it as a program. Okay, a program is nothing but a collection of instructions. We will see how we can execute a single instruction, and then we will move on and we'll see how we can execute multiple instructions which constitute a program. Okay, and I give you a example that how we human perform task. So that is what you remember always. And if you relate a human mechanism with the computer, you will understand everything. And memory is a very essential part. So I'll not extend. I know that you have your next class. I'll very quickly take the attendance. All of you send your attendance, guys.
Ma'am, in here?
Yeah, here you have to send.
Ma'am, we'll write our name or just present?
Your name and present.
Okay, ma'am.
Okay. But
Yes,
I'll
ma'am.
also take it. I'll also take it. You send it there also. I'll take it here also. Well, I should stop presenting first. Wait. Let me do that. Oh, guys, did you understand it properly, today's class?
Yes, ma'am.
Yeah, ma'am. Ma'am, can
If
you
you have
please
any doubt,
send this recording?
oh, I can share you the link, right?
Yeah,
Yes,
yeah.
ma'am. Actually, you could upload it somewhere or do something like Mainak sir does, no? Like
No,
he
but the point is
sends it.
that the thing is that I cannot save it. I could save the videos. So what do you want? Share you the links so that you can just see it from there, or upload it somewhere.
No, you can upload it somewhere.
Ma'am,
Like,
upload it somewhere and then you
like
can
you can
remove
upload
it
it on
from your.
YouTube and send us the link.
Yes, ma'am. YouTube and
Okay,
send it.
I will do that. Okay. So first take me the
Yes,
attendance
ma'am.
very quick.
Okay, ma'am. Thank you.
It's already 10:02. I don't want you to be late. Just a second.
No, ma'am, it's just okay.
Okay.